Hello everyone, it's the 11th of October still, and it's time to solve the 11th October Leetcode challenge. The challenge today is called Remove Duplicate Letters. Given a string S, remove duplicate letters so that every letter appears once and only once. You must make sure your result is the smallest in lexicographical order among all possible results. Note this question is the same as smallest subsequence of distinct characters. Okay, and the examples: input S, so the string is BC, so B and C are duplicated, and output is ABC because this is the smallest possible lexicographical order. Another possible answer would have been BCA, but it starts with a B, and obviously starting with an A when possible is better. And then C, the next one, CBA, CDCBC. So again, the C is, there are 4 copies of the C, there are 2 copies of the B, 1 copy of the A, and the D is also 1 copy. So basically, since A is only 1 copy, if we can start with A, we should start with A, right? Because C and B are duplicated. We have the B here and the C here, so we can start with the A. But let's say we did not have a second copy of the B, then we should have started with the B if we did not have the second copy here, because otherwise, if we started from the A, it would have been an incomplete solution. We would have been skipping the B letter. So let's try to think of some examples. I guess I need a notepad for this. I just need to write some words. So how do we do that? I mean, if we think about this, generally speaking, it would be very easy without the lexicographical order, right? So if we just say return any iteration where the words where the letters are only used once. So what we could do is we could have like a set of words visited. So like we could have a word characters visited, I'm sorry. So we would have chars used, which is like some sort of a set of character, and because using set because set is all of one operation to access the data there. And if we start with the first one, BCABC, we could just say, you know, in my answer, is B visited? Like I'm going to go one by one through the characters. Is B visited? Question: no, it's not. So in our answer we write B, and in our set of characters used we add B. Then C, is C visited? No. Then we add C. Is A visited? No, and we add A. And then is B visited? Well, yeah, it's visited, so we don't do anything. Is C visited? Well, yeah, it's visited, so we don't do anything, and we return BCA. So that would be a solution, but it is not the smallest in lexicographical order. So this makes it a much more difficult question. So another way would be to brute force it. Like if we can find one iteration, then we can find all iterations, right? So let's say we look through the characters, and instead of just saying is this character visited or not, we count the number of times it's present, or maybe the oh yeah, I guess we can do the count number of times. So how would that look? So let's do the exact same example again, but this time it will be multi-line, and we go through the string once. So this is our input. We go through this once. So we say like the first time we encounter B, we say B is encountered once. Then we say C is encountered once. Then we say A is encountered once. Then we say B is encountered the second time. C is encountered the second time. And then what we can do is we can again go through this. And now let's say if we encounter a B, as long as we have used it we have more than 0 uses remaining, so we have 2 right now, we have encountered it twice, we can split this like a graph. So we can either use the B here And then, I mean, if we use the B, we can basically treat this as removed. So we probably in our graph, we need separate map, like separate counters. So imagine this is our graph for on the left. We say, you know, B is already used. And to the right, it's so hard to write what I want to do here. Okay, I won't do it here. So on the left, we say use the B. And on the right, we say, well, B minus 1. Like we've already considered using a B, but we didn't use it. So we still have one more use remaining. So our answer is just an empty string so far. Then we go to the C. Again, now we need to split this. We either use the C here, or we don't use the C here. So on our second level, we have one remaining use of C. And again here, we can either use the C, or not use the C, or not use the C, and have one remaining. So this is how we're going so far. And then we go to the A. Well, A has only a single possibility, so we actually have to use it, right? We cannot not use it, because there will be no A later on that we can use. So this means that this will become BCA, this would become BA, this would become CA, and this would become just an A. And now we go again, next one. We used already the first 3 letters. The next character is a B. On this B is the last one, so we need to use it. But on the first one, we've already used the B, right? So we need to keep somehow the knowledge that we should no longer use the B. So since we've already used the B, we don't care about it here at all. So it just keeps on being BCA. The B here also used, so it keeps being a BA. The B not used here, so it becomes a CAB. And the B not used here, so it becomes AB. And then we're at the last C. So here again, C is used, so it just keeps on being a BCA. This one becomes BAC. This one has used the C, so it just stays as a cab. And this one becomes ABC. And this is the answer. But how do we know this is the answer? Well, we basically need to compare lexicographically all answers. So we actually computed every single possible answer. And we need to now compare the answers and find the lowest lexicographical answer. So I think this can work. I think this will work. But it's probably very slow and inefficient, right? At the very least, because we're going to be using a lot of extra memory to keep the knowledge of whether we've used the letter or not, and keep all the answers instead of just keeping the best possible answer. So let's try to see if there is an easier way to do it. Don't have water here. An easier way would have us use the indices somehow. So maybe either a combination of the counts of the letter and the indices, or just indices. So what do I mean? I mean, we have this A here, right? And we know that A is available only a single time, right? So basically this means we have to use the A by index number 2. I mean, by we get to this point. Because if we do not use the A, we will never get the ability to use an A at a later point. So at this point, it has to be used. For sure, we cannot not use it. So if I have somehow the index of A, so let's say I'll do the same thingy. This looks nicer if I use the other brackets. So I have A, and then index 0, 1, 2, A2. This means that by index 2, I have to use an A, right? If I don't use an A, then, I mean, I'm done for. Then for the B can be found in index 0 and in index 3. So this means I can use both of those B's, right? But I need to use a B by the time I reach index 3, because otherwise I'll be out of luck. I will no longer be able to use a B. And then on the C, I have on index 1 and index 0, 1, 2, 3, 4. So by index 4, I need to use the C. And now I can kind of reconstruct this. Like, I just kept the last index. I'm not sure if this is enough. I might need the first one as well. Will I? I'm not sure. I think I'm gonna try this way. So let's just see if this would work. So now, I mean, for this concrete example, it will work because it's obviously working. I'm just gonna say, well, from all of the mappings, give me the smallest one. Like, give me the one that I have to use by the time I get to index 2. So at this time it's an A, because the others can be used later, right? I can use both B and C at a later point. So I'm not like I can add them later. It's okay. I just take the smallest character, which is A, that is out of index. But let's say I had a Z here, and it would be like a Z equals 0. So then I would have to do like the answer ZABC, which again would be correct. Because if I have only a single Z and it's the first character of my input string, then I cannot delay it anywhere. And regardless of all the other characters, I have to start with a Z, with a Z. Wait, is it called a Z or a Z? Does someone know? Please tell me in the comments if you ever hear that. I always wondered. I think at school we learned that it's called the letter Z, but it kind of sounds weird to me right now. Anyway, so yeah, I think this actually makes a lot of sense. So I would just need to keep the last possible index, so I can obviously use them earlier. But can I, how earlier can I use them? I think it doesn't matter though, does it? Because as long as I can use them later, I can just order the smallest lexicographical string to begin with. So I think this is a valid solution. I'm gonna code it and run the Leetcode tests against it, since I'm not actually 100% sure. But it sounds kind of useful. So let's go with 11 and take remove duplicate letters. So what do we need to do first for my algorithm? We need to find the last possible place where a character exists. So this would probably be a map. So I'm just gonna say like last indices. How do you write indexes? I guess just last index, which is a map of character and int, and it will be get last index for indexes for s. So I'm gonna write like pseudocode as if I already have it, and then I'll go ahead and create these smaller functions, because I kind of prefer to do a top-down approach when I'm not 100% sure about what I'm doing. And so I have this already in our algorithm, not this one. This one seemed worse in this one. So if I have this map, then I need to start from... let's go back to the original example though. I need to start from the zero, start from the start, and then find the first, like the smallest possible index. I mean, even if I had the Z, it would be from 0 to 0, inclusive though. If I have the A here, like this one was count. This was the other approach, and this one is index. So start from 0. And then I think do I need to find the index or the letter? I guess I need both, right? I need to find, by the time I get to index 2, what is the smallest letter I can use? Because I could have had, more letters that end on the 2, right? No, I can't. But I can have some letter that ends on a 1, but then I would just take that one. But I have many other possible use cases of the C, but I don't want to take the C, I want to take the A. So I think what I'm gonna do, let's say I had some like bigger numbers here for the sake of the argument. Let's say my string was looking like this. So A was actually 0, 1, 2, 3, 4, 5. So it was 5. And again, my ideal string would be ABC, right? It would be ABC. Yeah, let's check this out, because this might invalidate my approach if it doesn't work. So I have this, and what I'm saying is, look at the string from 0 to B, which is on index 3. So look at this. I'm just having the last indices. So look at this substring, which is consisting of 4 characters, and give me the smallest possible character, which in this case is an A. And since I have the A, then I can write A to my answer, like this is the smallest possible character in this substring. And I can remove A from my collection, like remove it, and then continue from the next character as a start. So continue, if I take the A from 0, 1, 2, then I continue from 2 exclusive. So this means I continue from 3. And then again I say from 3 to the smallest possible index to 3. What is the best letter I can use? Well, there is a single letter, just a B. So I'm just going to add it. And then from the next one, from C, so from here to here, between these 2 characters, what is the best character I can use? After I have used the B, well, I actually have a single character. So I'm just going to add the C. And it would be correct. So I actually need to linearly go through the string, but I think that's fine. That's like totally fine. And this would work. So we go through our entire string and we start from 0. I'm doing a var outside of a cycle because in Kotlin you cannot really manipulate the i's in a for loop. So I kind of need to do it this way. So I have start 0, and then end is, what is end? From this map, the smallest possible one, because if I get a character that is only reachable until that point, well, I need to use it by that point. And in this case, I had the A at the 5, but since I used an earlier A, then I can still fulfill the C with the B, which is by the index 3, right? Because I'm using something before index 3. Obviously, if it's a different letter, it will come prior to the one that I have at the end in my inclusive range. Since I'm using the A here, it is not invalidating the use of the B at the last possible place where B can be used. So end is, well, find the least index. Find list index. And I need to probably pass this last indexes map. This is the list index. And do we need the character for the list index? I think not really. If I find a smaller character, it's gonna be before. This is just what I mentioned right now. In this case, I find the A, it's before the list index that I have, so I'm not gonna invalidate the use case. And if I do not find an earlier, like a better letter, so let's say I did not have an A here, and B is the correct the correct answer, well, I'm just adding the B. Right, I'm just adding the B, and I'm removing it from the letters that I care about. I'm removing it from the map. Yeah, so I think that works. So I'm doing this, and I'll say now for start to end inclusive, I guess I in start to end, I'm gonna say what is the smallest character. I guess I need to keep a reference for that as well. Var smallest char. Actually, I'm making a very bold assumption that I only have lowercase characters here. Is this the truth? Is this correct? S consists of lowercase English letters. Oh, okay. Because yeah, I should have done something else if this was not the case. But since smallest character is something that's between A and Z, then I can just say it's Z plus 1, right? So this is whatever is 1 after Z. So give me the smallest character, I mean, obviously this is an invalid one, but I'll have a valid one by the end of by the time I get out of this loop. So I'm just gonna say if si. So can I use the string as an array, or maybe I need some charet s. Oh, it just returns like this, just returns a character. So this should be good enough. If this is smaller than smallest character, I think I can compare chars in Kotlin, but I'm not 100% sure, so I have to check that. Actually, let me check that really quickly while writing this code. Print basically a smaller than z. This should be true. And 6 smaller than z. And 6 plus 100 smaller than z. False. Okay, so it works. It's basically just using the character as because characters are represented as ints in Java, so probably the same thing. So it should be good enough for my comparison. So if something is smaller than the smallest character, then I need to know what it is. So I have to save it somewhere. I'm saving smallest character is equal to si. And also for when I'm done, I need to make sure that my next start is equal to I plus 1, right? Because of this. Because if I take this a, so 0, 1, 2, if I take 2, then in my next iteration I need to start from 3, right? I need to go from 3 to 3 inclusive, which would be obviously the letter B. But I need to make sure I keep updating this start. And I'll probably have to do another loop as well somewhere, because I'm currently just doing a single iteration. So I'll need to iterate this quite a few times. So I have this. I have this entire thing. And by the time I'm done with this loop, that should be an inner loop at some point, what I have found is both the from the range between, like at the beginning 0 and 3, the smallest character that I can use. And I take that character and I basically need to append it to my answer. So I need some holder to hold my answer. So I'll just use a string builder probably. String builder. And I'm just gonna say by the time this is done, string builder append the smallest character I found. Okay. And this entire thing actually needs to be looped. How many times do I loop it? Well, I guess for each character, right? I need to loop it as many times as I have unique characters, because that's how long my string will be. My output needs to be only unique characters. So even if my original input is 1, 2, 3, 4, 5, or 6, I only really need 3 loops here, because I'm looping through the unique characters. So this entire thing will be repeat. I think I don't care about index there at all. I'm just gonna say repeat last index map size. So that's how many times I want to repeat this. Just move it here. And I think my answer is just SB to string. Oh, return that. So I just need to implement these two methods now. Get indexes for. So this should be pretty straightforward. I have to loop through this and keep only the last iteration, the last one that I found. So basically replace it. Replace the key with the last index I found. So a single iteration through the entire string should be good enough. So S for each character. I'm gonna say, like, let's say this is my map here. Wow, map is, I think it needs to be a mutable map though, because I'm gonna be, I think I forgot to remove the character somewhere where when I'm appending. I also need to do remove. As I was constructing the map, I was thinking about mutability, and that's when I remember to do it. But in order for this to work, I need my last index map to remove, which would be a mutable map. So remove the smallest character, and this would be returning a mutable map. So map is equal to mutable map of char and int. So as for each, I'm gonna say map dot map well, it. I guess I need for each index though. I need index for each indexed. So this is character, and which one is first? It's index and character. And I'm gonna say map character is equal to index. And if I find something only once, it will be placed only once. If I find it multiple times, the last index I find will be replaced. So that's when I'm gonna say just return the map. Return map. And find last index. Find least index actually. So I need to find find a character that by this time I will be unable to use it. So I need to find the smallest usable character within the range from start to this character. So this would be least character mutable map. Yeah, I'm just going through this, and I'm basically reducing it to the smallest possible. So can I do something like this? Dot map it dot value, and then min. So isn't this an int? Oh, it's a int question mark. So if here I have empty map, this would be, oh, I guess I should never have an empty map. Can I have an or? Was this the syntax? But yeah, I'll return -1 if I don't find anything. But this should never happen, I think. Okay. And now I need to fix this start, since I'm mutating it here. Need to make sure I don't return it to 0 every single time. And I think, am I missing something else? I'm trying to find the smallest character, but smallest character is not enough. I need the smallest character to not have been removed before, right? Because I can find multiple times the same A, but if I've already used it, I should not add it again. So this if is actually wrong here. If si less than small character and last in the, how do you write indices? Indexes. Okay, so last indexes. I wanna, because last index was confusing me since it's the name of a map. So, and last index contains key si. Yeah, because otherwise I don't want to do that. And this is the inclusive one, right? It's inclusive, and then I'm starting from the next one, and then end is also guaranteed, or I think it's guaranteed to be bigger than what I currently have, because if I take the smallest one out of the equation, well, then I'm only left with bigger ones. And in my concrete case, I'm taking the B here as my range. So I'm taking from B, C, A, B, this range. I find the A, the smallest, but A is on index before 3. So now I remove the A from my equation, but again, I'm left, since A is before 3, then I'm left with something that is definitely within the range of 3, so I can return back to this. So basically I'll find the same end, but my start will be 3. So it would work. I think this is actually a valid solution, but I'm not entirely sure, so I'm gonna test it here. If it doesn't run, I actually think it might run from the first time. Thinking about it, makes a lot of sense. But if it doesn't work, I'll write some custom test cases in my code. All right, nice, it's accepted. Whew. This one was a bummer. I doubt it's the most optimal solution. There probably can be better solutions. So what's our complexity? So first, we're building something. So we're taking O of n, this map. And also we need, in the worst case where you only have unique letters, we also need O of n space. So at this point, we already have O of n runtime, and n is the number of characters in the input string, and O of n space, where we create the map. So from here, we do the string builder, it's whatever. This is whatever. We repeat number of last indexes. So this is at worst O of n again. So if they're unique. So this is O of n again, this repeat potentially. This is O of n. This can be a val, I guess, since we are created every time. This is whatever. This one. So how many times can we iterate here? Because this is our nested part. I mean, if we have only unique letters, which was my case for this being O of n, then the least one will be first 0. So this will be 1, and the second time will be from 1 to 1, then it will be from 2 to 2, then it will be from 3 to 3. So this would be actually only a single iteration in the worst case. In my current example, that I have some duplicated letters, like this one, then I'm iterating from 0 to 3. Then I'm iterating from, but if I took the A from here, like let's say I had an A here, so I'm iterating from here to here, and I actually have to go through the entire motion, because I didn't hardcode somewhere that A is the smallest possible character. I could have done that though. I could have optimized a little bit, but let's say I didn't. It's just my solution. So I'm doing 4 checks here. I'm taking the A. Then I'm doing here 3 checks. Let's say I took this B here somehow, because I actually can take it. Then I'm doing these checks, whatever. I need to go quite a few times through the entire string. How many is quite a few though? Because it kind of feels like I'm actually going a bunch of times through the string itself. Like, I think at the very worst, this would be the number of characters in the alphabet, like 26. Because by the time I remove 26 characters, I will not have anything else stored in my mutable map, so I will no longer iterate anything. So in the case where I don't have everything unique, but I have like all possible 26, I think they're 26, right? The English alphabet. I might be confusing. Letters in English alphabet. 26, okay. So yeah, I have 26. So I can, at the very worst, run this 26 times. And then by the time I'm removing indexes from my indices map, then this will be faster and faster. And smaller ranges will be used. So basically, I think my solution is 26n or something like that. Because here I have like very simple like comparison, assignment. This is pretty free. This one is O of 1, just appending something. This one is O of 1, just removing something from a map. ToString is also, I guess this is O of n again, the ToString method. But yeah, a bunch of n. I mean, it's not an order of magnitude more. I guess if n is very small, I mean, you can say it's n times m, where m is the size of the alphabet, right? But since we know it's 26 because it's small characters, then it's like, we can say O of n and be kind of put our happy face as if it's really O of n, but it's not really O of n. It's a bit more, like, quite a bit slower. But it should work for even bigger strings. I think it's a pretty decent solution. Okay, let's check the... Again, solution is locked. God dang it. Let's check the other solutions. So, O of n, a recursive greedy solution, Java using stack with comments. Yes, let's check a couple of solutions. Given the string, the greedy choice, the leftmost letter in the word, is the smallest SI. Given the string as the greedy choice is the smallest SI, such that the suffix contains all the unique letters. So this is basically what we're doing. We're taking, like, we need to find the leftmost letter that cannot be not used. Not that when there are more than one smallest SIs, we need to choose the leftmost one. Why? Simply consider the example ABC, 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 ACB. After determining the greedy choice, we get new string, removing all letters to the left, removing all SIs from S. How do you do that in a, like, fast way? Oh, he also has a runtime of 26n. Nice. With the recursive, we solve the problem. So he basically, he takes the leftmost letter that's the best that he can take, and then he removes all previous letters since he doesn't care about them. Basically, substrings them, removes them totally, and then also this concrete letter he removes all places where it's encountered from the rest of the string, since obviously it should not be used anymore. So how does he do it? He has this. I always find it funny when they say "count" for the count. So count is int 26, position is 0, this is the position of the smallest SI, so he goes once through the entire string and says count for the character of, I mean minus a basically, for a is minus 0, for, yeah, it places the small alphabet letters into boxes within an array instead of a map. I actually prefer using a map. I'm not sure why some people insist on over-optimizing with this, because I think map is easier to read. But whatever, I digress. So he finds the count. This is like similar to our solution, but I was not sure how to proceed with this solution that we had here. So he goes once through the entire string. Then he goes through this again and says if the character at the current index is smaller than position, so position for the smallest SI. We didn't move the position yet. So if the character is smaller than the character at this position, then position becomes this. So he wants to find the smallest position, the smallest character possible. And he stores the position of the smallest character possible. And then he says if minus count of the character at this position is 0, then break. Why? Well, because then even if it is not the smallest possible character from all characters, if this is the last time you encounter this character, then you need to use it. You cannot not use it. You have to use it, because otherwise you will no longer be able to use it later on. So return the length equals 0, then small empty string, or this character plus this recursive solution from starting the next position, and then replace O Replace all encounters of this character with empty string. So this is again, this is an O of n operation. Substring I think is also similar to O of n. And this one is O of n. And this one is O of n. But potentially breaking a little bit faster. I mean, his solution is probably as good as ours, right? And as he says, it will be at most 26 times the recursive calls, because by the time you call it 26 times, you will have removed every single character from the alphabet and you will have an empty string as input. I feel surprised nobody mentions replace all method is ON. This is the reason why the solution goes slow. Check the result. Check this, returns wrong result, reset. Easiest solution in no time complexity, follow this tutorial, blah blah blah, whatever. Okay, whatever. I mean, it's an okay solution. I would personally not have used recursion. I highly dislike it, but for problem solving, it's totally fine. Java solution with stack. So he didn't explain what he's doing. But again, he has some holder for ints. He has visited. This counts the number of occurrences. So again, he counts number of occurrences. Container if character is present in the stack. Converts the string to a character array. Counts the number of occurrences. Creates the answer stack. He has an index here. Then goes through all the characters. Why does he call a character array ch and then the character is called s, like string? Oh my god, this is so terrible. I'm sorry, person, I don't mean to be mean to you. You probably have a nice solution. I just really hate when variable names are so weird to decipher. But anyway, arrays index minus minus, so he decreases it when he finds something. If it's already used in the stack. Oh, so he keeps this to know if some letter has already been used. So if it is used, just whatever, go to the next character. If current character is smaller than the last character in the stack, which occurs later in the string again, it can be removed and added later, because the remaining string ABC can be used to pop. So he would add a character, but he would then pop it if he finds a smaller character. But how will he pop it in constant time? He will say if it is not empty, if it's smaller than the peak, then and there are remainders. Okay, so he picks again. He picks twice, and if the character doesn't have any more occurrences of the same character, then he would probably not do it. He would not do it, because then he would not be able to add it later on. So he pops it. He'll say that this is visited. The one that he is popping, he will say that is no longer visited, and then he will push the current character and say that the current character is already added. And this check here, it actually makes sure that you don't care about the same character when you encounter it later on. But if you decide to remove it, then you would care about it. And then he has a string builder. Well, the stack is not empty. Yeah, and this actually works because of this check. Without this check, this would have failed, because this check ensures that you're only popping characters that you can find later on. This is very important, since you are decrementing the number of remaining characters when you encounter it. This means that you will not be popping a character if you can no longer use it. Does it work for every solution? I mean, it's pretty interesting. It's a very interesting solution. I'm like, intuitively, it feels like it might fall short with some cases, but I guess the person checked it and it works. So that's pretty neat. Okay, so we took a look at two solutions. This question was actually a lot more complicated than most other questions that I've solved. So hopefully this 44-minute video is worth it for somebody else who is struggling to understand this question. I'm pretty sure that if I don't do this video format, if I just like take solve the entire thing on my own offline and then present the solution and only explain why it works and make the videos like 5 to 10 minutes, they would be much easier to follow along. But I really hope that this format is useful to somebody, and at the very worst, as I always say, it will be useful to myself in 2 years' time to look back at how I've progressed or digressed with my knowledge. And yeah, if there is anything you'd like to ask, I'd love to hear about it in the comments. See you again tomorrow. Hopefully this was useful.